And welcome to my talk. Thank you for being here. So we had to do this small alerting drill for the whole Germany to welcome you to this talk. This is wonderful, that worked. Okay, so let's get started. So my topic today, I think this is okay. We have to deal with this, so don't worry. Just switch it off. We are all safe. Don't run out. Yeah, so my topic today will be to share with you some experience as we were building table soccer backend using CQRS. And that's me. My name is Simon. I work as a consultant at Holisticon. I'm primarily backend developer, software architect, and very interesting in subjects like domain-driven design, CQRS. I do most of my work in Java or Kotlin preferable. And yeah, so if you have any questions to that, you're welcome to ask me. Short introduction of our company. So we are IT consulting based in Hamburg and started about 15 years ago. So now we have 3 locations in Hamburg, Hannover, and Kiel. And we do a lot of stuff along with classical software engineering. We also do some business process automation on security and smart data. And of course, we are agile. And of course, we are hiring, as everyone. Yeah. So if you're looking for a cool crew, then welcome. OK, so back to the topic. So what was our mission and why we decided to do so? So we wanted to build a mobile app. It's kind of easy. So the mobile app should be used to record table soccer results, so well known as Kicker in Germany. And the idea was not only to record this, but also to provide you some personal and team statistics and to support some more professional clubs and maybe leagues and competitions and whatever. And should be applicable to individuals. So if you go around in the evening and want to play soccer with your friend, then you can just pull the app, put it on the table, and record your results. Then there is, of course, a corporate use, very important. Many companies have this table in their headquarters to give you some slack time. And of course, it's a very important question, who is the best player in the company, right? And we also have contacts to some professionals. So we are supporting women's table soccer team, which are pretty popular because they won the last European championship. And then some individuals also won, I think she's number 2 in Europe or something like this. So these are kind of different kind of girls, and they win 10 of 10 and 100 of 100 against you, and you can watch and learn all the time from them. But they are interested in very, very specific data about table soccer. So they do a completely, it looks similar, but it's a completely different stuff. And of course, we wanted to learn and to have fun building this, because we are primarily not an app company. Primarily by corporate customers doing some enterprise shitty backend for whatever reasons. And this is, of course, completely different stuff, right? It is a real product development for building an app, build it to the app stores. And of course, for us, it was technology exploration. So we wanted to try it out. How does it feel? We are not, so we have a core team, about 5 developers, and we are doing all the development in our Slack time. So we have this 20-80 rule. 80% for the customer, 20% for fun projects like this one. There are more people on the slide, but yeah, people are involving, coming and going, and some of them more, some of them less. Okay, so let's speak about the problem space. You think table soccer is simple, right? So why what's the challenge there? You have to score 1 goal more than the opponent, and then you probably win the game, right? Then we found out it's actually not that simple. So first of all, we did this, driven by domain-driven design. So we tried to identify our domain concepts, our core problem, and so on. And it is so fuzzy because, there is no, you have like game, and sometimes, we call them matches, and sometimes you have something like match sets. So you're not playing only one game, you're playing like 3 sets in a row, and then you win it. And then we identified, okay, everyone actually has a different set of rules. So if you meet on the table, you in the beginning you usually have this like, and how you count this? Are we playing till 6 or till 10? And do we have switch sides after one game set match set is over or not? And is there a draw or not? And are we playing on time or without? And it was crazy. So we identified that everything is actually configurable in this game. Nothing is stable, but the fact that there is a table and someone can score. Then we thought about privacy a lot, especially about GDPR, because kind of being a little bit GDPR and privacy aware, you want to record your table soccer result. Maybe it's not a good thing to share the entire account data with some app, right? So I'm personally the guy who says, I can just move these counters on the bottom, and that it works too, right? So there should be a balance. And of course, scalability, right? I'm building an app, bring it to the stores, and you never know what happens next. Maybe 10,000 people download this and start watching their results. So there should be some kind of embedded scalability. So the idea of the app is, that to play the game, you just put 2 phones on the table, and then as you score, you just tap on and then record your results, right? So this is the more kind of classic idea. But we're here to speak about technology and approach a little bit. So as I said, we started domain-driven design to explore the domains. Of course, we are doing this agile, and of course, 20% of slack time is, it prolongs every single step of development to an incredible period of time, because you're just doing it once a week, right? And then you have a week pause, and then you do a little bit again once a week. So what we opted in is for the front end, especially for the app, to use Angular Mobile. So Angular SPA actually packaged into Capacitor, which is kind of an app shell around the website. And we also have a desktop version where you can easily look on results and so on. And we opted in to build a JVM-based backend. So today we will speak actually about the backend, as the title already said, and hopefully Timo will explain next year how the fancy front end looks like as the app is already distributed and everyone already installed it. So for the backend, we went the way to look on hexagonal clean architecture, CQRS AS. Who's been to the previous talk in the cinema about event sourcing? Wow, that's good. So he said it's actually not required to do CQRS to do ES. That's true, but we did exactly that. So we have both in combination. So now we're kind of building up to this talk. The whole backend is programmed in Kotlin and Spring Boot using Webflux stack, so reactive. And we said there should be a framework that can support us, and there is a framework that supports us, and that's Axon Framework. So we use a lot of that. But then a lot of short acronyms on the slide. So who is aware of what a clean architecture is? Around the third, maybe. Okay, then I will spend a little moment to do this. So you have this classical tiered approach. Probably everyone knows tiered approach, right? Tiered architecture, layered architecture. Here you also have layers, where they're not from top to bottom or from bottom to top, but there are circles. And that's the only difference. No, that's not the only difference. So you will think about this more about inside and outside. And outside, you have usually kind of integration technology. So you have an infrastructure layer that adopts this integration technology to your application. So the requests come in usually using HTTP in nowadays, or it could be also some kind of messaging or whatever. And if you store data outside, you'll usually use any kind of a database or data storage or event store or whatever. So this is outside, right? And this infrastructure is used to adopt this technology actually to your application. And the application is usually defined by your main use cases. So you're modeling your use cases and you say, okay, the application should do this or that. And all this code goes to the application layer. And inside of this application layer, we put a domain layer, which is actually less about the solution of your problem. It's more about your problem space. So there are some concepts that the application is about. In our case, it's the table soccer. And there are some concepts there. So there is a table, right? And there is a score, and there is a goal. And these are completely independent if we are programming a scoring application or something else. It's just a part of this problem. And this problem space is actually implemented inside of the domain layer. And the interesting rule about this picture is, there are not many, there is exactly one, that all the dependencies should point from outside to inside. And that means that your domain layer actually, let me go to the next slide maybe. So if you go from outside, you see these adapters, in adapters, they invoke your use cases, which are part of your application layer. And the out adapters are used to invoke technology again, right? But the inner layers are constructed in a way that the domain is completely technology independent, because it's not pointing outside, right? It's only can reference something inside, and the application can also actually only use this domain layer for the implementation. And everything that goes outside, you define these ports, which are interfaces, and then you can actually exchange technology behind of this. This makes the system very robust and also future-proof, because you can change technology and you can change technology decision without modifying your domain logic or your application logic. And there is this book, and I realized that there is a second edition, and I was some time ago reading the first edition, Get Your Hands Dirty with Clean Architecture. It's a very good read, and I emphasize you to have a look on that if you want to learn what it is. Okay, what is CQRS ES? Who knows that? ES, of course, everyone, right? Because you have been just to another talk, right? So ES stands for event sourcing in fact. CQRS is an architectural pattern separating the write side from the read side. So it stands for command query responsibility segregation, very long term, not fitting to any PowerPoint. So command side is the write side. So if I want to modify the system, I'm sending commands. And query side is kind of is clear, right? I want to query data, right? And so there are two independent models for this. And once the stage is changed on the command side, it is eventually transferred to the query side. So there is an eventually consistency gap in between. Sounds a little bit complicated, I know. The advantage of that is that accepting a command has nothing to do with reading data of the output of that command, right? And so if you use the classical approach of mutating shared data between these two parts of your application, you're always taking a compromise to say, okay, for validation, I need those fields. And for the query part, I know the other fields. And how do I build effective persistent projections that, for example, serve both, right? And there are some, of course, it's more complex if you separate this, but there are some benefits of doing this. For example, if you have functional and non-functional requirements, that your command side and the query side are different, which is actually the case in our scenario, because my command side is I'm scoring goals, right? And my query side is I'm reading statistics, how many goals have been scored over a period of time in this game or in this team or in this whatever, right? So they of course, they're related, but they have completely different natures. And also, non-functional, there are less players playing, and there are much more people then watching and reading the results, right? So it will be, from the performance requirement, it will be a system that is much more querying than actually sending commands. And another very good thing is it's very adaptive for incremental development, because you can build these query models later on, right? And this is because of actually the event sourcing. So the event sourcing is the persistence strategy, as already told by Ole. You don't store this state and mutate the state all the time, but you're storing the entire stream of events that occurred in your system. And then you can rehydrate the state from this event stream every time. And you can build different projections for different queries, for example, or multiple projections, and project them differently, and then have this optimized stuff. Okay, so this is how it usually, like on an architecture diagram, how it looks like. So so you have your use case, which now says, I want to modify state. So this is, in this case, it acts as a command dispatcher, sends some command to an aggregate validates this command, if it can be received or not, emits an event if it can be actually accepted, and then on the query model side, there is some projector that is used to basically build some data based on this information transferred by the event, and then you can query it for the specific projection. So this is kind of a classical approach how you build CQRS system to name all the guys. There is also a policy, but that doesn't matter. And this domain event that goes from the command part to the query part is actually something you can also store and, of course, use then as a primary persistence. Okay, let's go back to our problem, to our table soccer, enough architecture for the moment. So we split our problem to several subdomains. So we identified there is the actual gameplay, right? People are standing in front of the table and doing scoring. And then the game should tell you, actually, you scored 6 goals from one side. This match set is over, right? You have to switch sides, for example, because we configured this in that rule. Then there is account. So we opted in to create an account. We wanted to avoid this, but then we said, getting personal statistics is much easier if you have a personal account for the app. Then, of course, statistics, one of the main forces to install the app and use the app. And then we also thought about something like tournaments, which is basically set up games, right? Where you say, okay, I have something like a league, for example, and these are the clubs that are playing inside that and how they should play, what's the game plan, and so on. It has nothing to do with the gameplay itself, but which games needs to be played. Yeah, and then let's look on them. So starting with gameplay, that's essentially the core, right? So if you're playing table soccer, the main concepts are to score goals, and of course there is a goal, right? Usually you play in something which we call match set, right? Or German Satz, right? To say there is this one part of the game, like in tennis, and then there is a whole game, we call it a match, right? And then obviously there are participants that can be humans, that can be unnamed teams. You could say it's Germany versus Italy who is playing currently, so you don't need to have named people behind of that, right? You can also play 2 against 1, 1 against 1, 2 against 2, or whatever. Every game takes place on a table. There are some rules determining how the gameplay is working. And we also introduced this concept of a room, which is kind of an abstract place where the tables, rules, and participants are located, right? So if you install it in a company, probably your company is a room, and then you say we have 2 tables, and then we have some sets of rules we're playing for. So the main challenges was that we identified that actually the rule influenced the gameplay totally. You can make a completely different game out of that. And as we were first thinking of this like being a configuration, actually. Then we identified, no, it's actually not a configuration, because the whole game and the whole history of this game makes only sense if you know the rules. So you can, for example, for the statistics, you can actually only compare games with certain attributes stored in the rules, because then it would be kind of strange, right? If you sometimes played like 7 match sets and someone only won, and then you say, okay, I won, I'm counting the number of games won. It's not very clear what it is, right? So you need these rules, and this is not a configuration of your particular setup. It's part of the game. The other interesting thing that came actually from the professionals play with referees, and the referees may say, yeah, of course the ball was in, but actually it's not a goal. So they have something like a visual assistant, video assistant, and whatever, and they can take the last goal back, which gives you, in any situation, the possibility to make an undo, which is very nice to implement, as you can imagine, especially in stateful systems. So you're building a state machine that can ever go back to a previous state. Yeah, so again, speaking about the command side, so as I said, of course, you need to set up the match somehow, and then the main command is score a goal. Score a goal, score a goal, score a goal. Then there are some others. So the system might say, okay, in your rules, you configure that you have to change side for the offense-defense player after the match set is over, or you have to switch sides of the table to make it more equal, right? So these are, of course, also kind of commands. And then there's also a match lifecycle saying, okay, I want to start the match, I want to stop the match, maybe I want to pause the match because I got a pizza, something like this, right? And the query side, matches in the room, table state, score, so everything that relates to this domain contents. As an implementation, we decided to do a functional core imperative shell, which is kind of also a pattern to say that the domain core is contained of pure functions. So no state mutation at all. And the state mutation happens only on the application layer, where we bind actually the game core to our application logic. And that turned to be a very good thing, because of course, testing the state machine is much easier if you say, okay, I definitely, if I am in a valid state, I can only go to a valid state. There is no way out there, right? We have 2 aggregates, which is room and match. So we split this apart. Otherwise, if you have 2 large rooms with many matches happening there, it will be a little bit overcrowded from the commands that needs to be received by these aggregates, by these entities. And of course, as we split it, we detected the downside, which is if you need to synchronize the room and the match, then you need something in between. And there is a saga pattern for this. So we use it for something like revenge or abundant match. And there are some patterns, some sagas we implemented. For the projection, we implemented the server-side event push of the updates, which is then very nicely integrated into the Webflux stack. So we're actually pushing any notifications. And once the match is started, the app actually subscribes to that and then gets all the updates through that. Okay, next one. Next one is account. A little bit trivial, right? So I need an account, I need an entity to represent a human. And having an account, I can join rooms and become a participant in that room, and then I can give me a nickname and play there. The interesting challenges I want to mention is especially authentication, because account is usually very close related to how you identify yourself. And this is usually not event sourced. So our entire system is event sourced, but this one is, of course, I will tell you later what it is. It's external, connected via REST, and it's not event sourced. So the question arises how you synchronize an event source system where you can only append events and you are not allowed to mutate them to something where you can just go to the database and just change identities and delete rows and whatever. And then you're in kind of a locked state. And it's at least we identify these issues, but it's not finally solved yet. But you need to address this. So build synchronizations between the external non-event source system to your internal event source representation. Fraud detection was also like a technological spike to say, can I identify actually a fraud game that is, just sending me some results? And account gives us a possibility to ask people, for example, to confirm that they play actually this game or something like this, all 4 of them. Yeah, command side, account lifecycle, room administration, as I said, query side, room membership, account information, also kind of clear. So we integrated with Firebase authentication, worked very well for us, actually. One of the main advantages, you have a very easy social login. So you can log in with email, password, whatever. And then you have to verify the email on your own, or you can say, I'm using my Facebook account or whatever, which is especially for the individuals and an app, a good idea, probably. Yeah, then we have this email confirmation. As I said, if you register with an email, you need to verify that the email is actually correct, which is a process, right? So you send an email and you wait, someone clicks on that, and then you need to keep up from that point. So it's completely asynchronous. And there is also usually deadlines, so you don't want to wait forever. Usually after 2 days, you say, okay, probably it was just someone spamming or whatever. And again, you need a saga pattern to do this in an event source system. So someone who keeps track of this to happen eventually, right? And there are also ways of, of modeling time in the framework that we're using. So you can say there is something like a deadline manager that jumps in after 2 days and says, okay, probably this account never existed. We just forget this. And do some compensation, of course. Okay, statistics. Yeah, the main reason why you should install the app, right? Looking where I am. Main concepts were metric and ranking. Metric is kind of clear. That's the value itself, right? So something like how many goals I scored in whatever. And ranking is for a certain group of people, you want to say, okay, how I am in comparison to others. Right, so that's the only difference. And probably for every metric, you can create a ranking if you have to scope just the people. What we identified, there is an exhaustive amount of available and possible metrics and rankings that exist. And of course, if you're just doing some computer gaming, then of course, everyone is doing any kind of metrics. And for us, being 20% select time implementing metric, we said like, oh, wow, that needs to be very iterative. So we can't do that now. We can't implement 200 metrics and then go live. We need to start with 5 and then maybe ask people what they want to look at. And the other issue is most of these values are time-based, right? You're interested in number of goals in last month or since the beginning of the app. So not very relational problem, I would say. And the other problem is that especially for ranking, you're scoping in different in different contexts. So I want to rank myself in a room, in a company, in whatever, right? So again, not very relational problem. So interesting here is we don't have any commands. So we are not modifying the statistic subdomain in sending it as something. But instead of it, we were producing so-called milestone events. So from the other context, we summarize some information and send so-called milestone event. For example, for the entire match, after the match is finished, we send one event with the entire information instead of 25 or whatever in saying one goal is there. And that's much easier to handle. For the query side, of course, you want to know what kind of metrics exist. It should be dynamic, of course. We don't want to build it fixed in the app, but it should be kind of auto-discoverable mechanism for that. And for the projection, we used InfluxDB, which is, I don't know if you are aware of that. It's a time series database, which makes you very, I will tell you in a moment what it is. Then for discovery, we use these scatter-gather queries, where you actually do something like a multicast query, who is responsible for providing a metric, and then we get a response. And we also use, and we also designed it to be incremental like this. So there is no list of available metrics anywhere. We just implement new metrics and they are registered kind of magically. Okay, so
Importing backing services. So to run the application, as I told, the application is currently packaged as a monolith or modulith in a Spring Boot, but we are planning to split it up, especially split up the projections. So it will run in Docker and then basically self-hosted. And then, so we're using Axon Server, which is gives us a main communication backbone for these command, query, and event. And as soon as we distribute it, it gives us also the location transparency. So you don't need to configure anything. You just deploy a second service nearby. It registers on the Axon server. And then you get the same information it would be locally, right? So that's one of the very important issues there. And in addition, the Axon server itself is an event store. So it provides you with a very robust, high-performance database for storing events. And not only events, but you can also store snapshots there. And so it's designed for high throughput, so they compare themselves with other systems like Kafka and so on. And if you come up with, I have 100 messages a minute, they say, okay, you will probably take the smallest tier. You don't need anything. It will just work. And you can add zeros to the number until they start thinking of increasing the infrastructure. So it's very powerful. So Influx, as I said, time-based projection, as we used for time-based projections. And there you have these time frame operations. So something like a sliding window is very easy to implement, very efficient implemented in Influx. So you can say, give me always the last week, right? And then you don't need to mess up with, so you have an operator for that. Probably if you're using Grafana and Prometheus, so Prometheus is another time-based with its own ecosystem, but they are kind of comparable in terms of storage, way of storage, and in terms of query models. So you also have a query language where you can do such stuff. And Firebase, it was a surprise for me. It just works. It's not not much to say about that. We were really thinking of hosting own Keycloak for that, and that said, hey, why should we do this? You can just get it from the cloud, and it's ready and it's done. Especially for the apps, sometimes you need to store data, and then you can use the file store, the Firestore. Okay, lessons learned. So what I want you to consider. So we identified that this approach of hexagonal clean architecture is definitely worth it to try out because it makes your code base very clear, even if you have multiple contexts and multiple modules implementing different aspects. This bound context separation allows you to make local decisions in your subdomains. So this functional core imperative shell is only implemented in one place where it makes a lot of sense, but you don't have to do these global decisions for the entire application. Kotlin is a magic fit to, but I'm a little bit biased. I'm a very big Kotlin lover, especially if you model domain types. So if you're doing domain-driven design and you don't want to deal with strings and ints and whatever, you want to deal with players, participant names, and goals and scores, and you can very elegant expresses in Kotlin. It's a good idea, and of course functional stuff. Function is the first citizen. There, Axon Framework. If you're doing domain-driven design with CQRS on JVM, definitely look on this framework. If you don't, also look on this framework because now there are ways of not doing Java but still use at least Axon Server. So then you get this massive number one player in the room into your ecosystem. And what you should definitely do is apply strategic design at the beginning, understand your domain before you start coding. Read the book about clean hexagonal, give CQRS a chance, especially if you have an asymmetric load on read and write side. Doesn't matter functional, non-functional. Kotlin, Axon. I'm a little bit out of time. If you're interested in the app is currently in private beta. It will arrive very soon in the stores. So that's the link down here. There you can just subscribe for a newsletter and then get notified if it happens. If you want to ask me something or our company something, there is another code.
Thank you for listening. And I think we still have some time for questions.